Welcome to This Explainer. Today, we're looking at a massive shift. For years, we've been reading about all these theoretical breakthroughs happening in isolation. But right now, we're exploring what happens when decades of that science finally graduate into tangible, everyday utility in 2026.
To really grasp the sheer scale of the technological acceleration we're living through, we have to look at the transition from concept to execution. Because the focus of our time together today is all about utility. Seriously, what actually happens when the things we've only theorized about leave the laboratory? Let's look at a few quick examples.
First up, think about AI. We're no longer just talking about a neat tool that helps you brainstorm or draft an email. We're looking at systems that autonomously execute complex, multi-step business operations entirely on their own. They've graduated from being helpful little assistants to becoming fully autonomous digital workers.
Or take the environmental sector. Researchers at the University of Adelaide are literally using raw sunlight to dissolve PFAS, those notorious forever chemicals, into harmless substances like fluoride. I mean, that is just completely practical, immensely useful applied chemistry.
And maybe the most mind-bending example? Neurotechnology. We're watching brain implants cross the line into clinical reality to heal the human hardware itself. Real patients are using these right now to control devices and restore their speech. It's happening.
Which brings us to our first major shift, the rise of the autonomous digital workforce.
Look at how fast this is moving. Just a couple of years ago, we were entirely in the chatbot era, where AI was a thought partner and you really had to hold its hand. Today, we've firmly entered the agentic era. These systems have persistent memory, they browse the web, they query databases, and they plan and execute goals completely autonomously. The sheer utility here is just off the charts.
And the market has definitely noticed. Enterprise spending on generative AI just hit a staggering $37 billion. That's up from just over $2 billion a couple of years prior. This absolute explosion in spending is driven entirely by the demand for this new execution layer. Companies aren't buying novelties anymore. They're paying for highly useful, scalable digital labor.
You can really see this reshuffling the deck in the coding space. Anthropic's Claude, for instance, has grabbed a massive 54% of the AI coding tool market, totally dwarfing OpenAI's 21% share in this specific arena. Why? Because it successfully ingests and understands entire codebases to build new products at unprecedented speeds. It is the ultimate utility belt for developers.
And this execution isn't just digital. In the physical world, humanoid robot manufacturing costs plummeted by 40% in a single year. That shattered the expected 15 to 20% drop. This massive cost reduction is exactly what pushes these machines out of the lab and onto actual factory floors. They're finally becoming commercially viable, incredibly practical tools.
But some of the most profound leaps in utility are happening inside us. Let's look at healing the human hardware.
Take David Liu's 2025 Breakthrough Prize-winning technology. We now have highly functional gene editing platforms that literally rewrite our genetic destiny. They go in and precisely correct mutations right at the source. This is no longer just a cool concept. It's an actionable, deeply useful platform for curing diseases at the molecular level.
And this translates to immediate clinical impact. Look at Life Biosciences. They just locked in $80 million and gained FDA clearance for phase 1 trials of their ER100 treatment. They're actively going after blindness caused by optic neuropathies. The lab science is graduating into real-world human trials to provide real healing.
The pace in neurotech is just breakneck. Brain-computer interfaces, or BCIs, have leaped from animal models to widespread human application practically overnight. We went from early implants for computer control in 2024 to FDA-cleared ultra-thin brain films in 2025. And now, we've got over 90 active clinical trials running globally, all aimed at restoring motor function in speech. It's breathtaking.
Of course, fixing our hardware doesn't mean much without a habitable planet to live on, which brings us to powering and protecting the planet.
For decades, fusion energy was that dream where you always had to put more energy in than you got out. Just look at those numbers from the 90s, well below a Q value of 1. But the dense physics data from the National Ignition Facility proves the game has changed. We finally crossed that threshold, hitting a scientific gain of 1.51 and then 1.89. We're generating net positive energy in a lab setting. It's a massive step toward the ultimate utility, limitless clean energy.
Now, while we wait for commercial fusion to scale up, we need practical solutions today, right? With the massive explosion of AI, data centers are eating up so much power. So researchers have engineered these novel cooling systems that slash data center cooling demands by 40%. That is an immediate, incredibly useful intervention to protect our power grids right now.
So how do all these disparate breakthroughs actually connect together? Let's talk about the translation to impact.
The answer lies in the next generation of connectivity. Global telecom researchers and the National Science Foundation are already deploying 6G architectures, specifically the Safe 6G framework. And this isn't just about faster downloads for your phone. It's an intelligent framework built to handle the insane data loads of spatial computing and autonomous networks sustainably. It actively balances optimal states for safety, security, and privacy. It's basically the invisible, highly useful utility belt holding our entire new digital world together.
Which brings us to the biggest question for all of us. What are the new rules of innovation?
Since AI has effectively commoditized basic ideation and coding, the shift in what makes human workers valuable is stark. To survive today, you need a very specific set of skills. You have to discover genuine opportunities through a sea of AI-generated noise, validate them with rapid experiments, execute at extreme speed, and build the market trust in human ecosystems that AI simply cannot do.
And as we integrate these wildly powerful tools into our lives and literally into our bodies, we really need to keep this framing from a leading bioethicist in mind. Our utility absolutely must prioritize moral inclusion and human dignity. If a BCI can restore someone's ability to communicate, it's not merely a product. It is a moral imperative to include them in society.
The bottom line is, the era of casual experimentation, it's over. As innovation leader George Chryssodakis points out, adapting to these tools isn't a luxury anymore. Innovation and adaptability are quite literally survival traits in today's landscape. If you don't react fast, you risk being completely displaced by AI-native competitors.
So I'm going to leave you with this thought to carry forward into 2026 and beyond. We are living in a moment where the cost of experimentation has absolutely collapsed, and the capability ceiling has just disappeared. When the barriers to execution are gone, what problem will you choose to solve? Thank you for joining me for this explainer, and I really hope this helps you go out and build something incredibly useful.